Hi guys, welcome back to the channel. So today we are going to be solving mark the elements on array by performing the queries. So we are given an array of nums and then we are also given n, which will consist of these many positive integers in this particular array. And then we are also given 2D array, which is queries, which represents each query. The each query represent the index and then some ki element. So initially all the elements which are present in the nums will be unmarked. That means it will be like 0 or it will be false. So we need to apply these m queries in an order like from 0 to m minus 1. And then for each query we need to do the following. Suppose let's say these are the queries and then this is the nums. So for each query we'll mark the index, whatever the index which is present in the query, we'll mark this particular index as marked in this particular nums, and then we'll pick k unmarked arrays in the array with the smallest values. Suppose we have one, and then we'll mark this as visited, and then we'll pick two more elements which are present in the array with the smallest values. And suppose let's say we have such elements exist, mark the if multiple elements exist, mark the ones with the smallest indices. Suppose let's say we have more smallest elements. We need to mark the indexes where we have smallest indexes. And then if it less than unmarked elements, we need to mark all of them. Suppose let's say it is greater than k, then we should mark only k elements. And then if it is less than k, then we need to mark all the elements which are present in this particular array. So let's go through the example. So we have a nums which will have 1 2 2 and then 1 2 and then 3 1, and then we are given queries which is 1 2 and then 3 comma 3. Now there is an index where we have 0 1 2 3 and then till 6, and then all the elements which are there in the nums will be unmarked. And then at this point, whenever we want to do the query, we need to return the answer where answer of I will be the sum of unmarked elements which are present in the array. That means suppose let's say at this particular point we where we do not have any mark, the sum will be 1 plus 2 plus 2 plus 1 plus 2 plus 3 plus 1, which will be like, let us calculate. So 1 plus 2 will be 3, and then 3 plus 2 will be 5, and then 5 plus 1 will be 6, 6, and then 7, 8, 8, 11, and then it will be 12. So the sum will be 12. Now, without doing any queries, the sum will be 12, and then our answer should be whenever we do perform the query, what will be the answer after marking all the elements and then after doing the query. So for the particular query, we'll pick the first particular query. For this particular query, we are going to say the index of 1 will be marked. That means this will be marked. This particular element will be marked. And then we need to pick two more elements such that we'll mark all of them. And then we'll remove the sum from this particular element. So whenever we mark this particular case, we need to remove this sum, whatever the nums is present in this particular sum, we need to remove that. So this becomes 10. Why? Because we want to remove the sum which is already marked. We want to return unmarked, so we will remove the elements which are marked. So the sum will be 10. Now we need to perform we need to pick two elements with the smallest value, and then we need to remove them. So in this particular array, this is done. So this is done. We need to pick two smallest elements. So we'll pick this one and then we'll pick this one. Why? Because these are the smallest elements and this is also smallest, but we need to pick the smallest indices. So we'll mark them as visited. So this will be, so this will be marked as 1, and then again this will be marked as 1. So this will be marked as 1, and then we need to remove the sum which is present. So we'll take out 2, this becomes 8. And then after these are done, we'll go to next query. So after we are done with this particular query, whenever we want to go to this query, the answer should be saved, which is sum equal to 8. And then when we move to this particular query, we need to mark the third index as visited. So this is already visited. We do not need to mark again. So we'll move to the next thing, which is these three elements, which we should pick those three elements and then we should mark them. So for this particular case, we need to pick the elements. So for the first time, we'll pick this one. Why? Because this is the smallest. And for the next time, we'll pick this one. Why? Because this will be the next, and then this will be the next. So let us pick all the elements. So first we'll pick this element, and then after picking this element, we are going to say this becomes 1, and then we need to remove this from the sum. So sum will be decremented to 7, and then after again we need to pick this 2. So this will be done, and then this will be done. So after that we need to mark this 2 as 1, and then again this as 1, and then we need to remove these two and then this 2 from the sum. So this becomes 2 minus 2, which will be 4, and then this becomes 3. After that, all the this query is done, so we need to mark the sum as 3. So this will be our answer. So if we see, we have 8 and then 3. So for this particular case, we need to mark these queries, these indexes as visited, and then we need to pick the elements which are the smallest value. When we have the smallest value, we need to pick those elements only, and then when we have a clash between the values, we need to pick based upon the indexes. So for this we are going to use the priority queue, where we will have the index, where we'll have index, initially we are going to have the value, and then again we are going to have the index, and then this should be minimum heap, so that it will it will have the top element as with the minimum value, and then with the minimum index. Suppose let's say we have the same value, then it will be sorted, it will be having the element on the top with the least index, so we are going to pick based upon that. suppose whenever we come here Suppose whenever we come here with this particular query as starting, so whenever we pick the first number, which is this one, so this one, and then when we want to query two elements which are present, now we need to pick the elements such that, yeah, whenever we mark this particular element as visited for this particular case, we'll reduce the sum, and then now we want to pick the two elements from the array. So this priority queue will give us the answer. So for this case, we are going to pick this one, and then again we are going to pick this one, and then again we are going to pick this one. uh, Only two elements will be picked, so we are going to pick this one and then this one. So whenever we come for the next query, we are going to pick this one and then this one based upon the value, and then if the value matches, we are going to consider it as index. So let's go through the code for this one. So initially we'll have the nums, and then we'll have the queries, and then we'll have the answer which we are going to return. And then we are going to have the priority queue where we'll be having the minimum heap, so that it will give us the minimum value which is present. And then if it has a minimum value, we are going to consider minimum index. And then we are going to mark all the numbers for this particular case as false. And then we are going to calculate the sum of all the elements, and then all the elements will be pushed based upon the value and then index. And then we want to do the querying for each query. So let us pick the first query, which is going to be I equal to 0, and then we'll take it that way. And then this is going to take the index, and then this is going to take the number of elements we need to pick, such that we'll do the marking for these particular elements. So initially, let's say if this particular index is not marked, that means we need to mark this particular index. And then we are going to reduce the sum by taking nums of index. So this is done, which is first condition, which is like this one: mark the element in the index if it is not already marked. And then let us take the second condition: mark k unmarked elements which are present with the smallest value. So for this particular case, we are taking number. So till number becomes 0, we are going to do the while loop. And then we are going to find the find the element such that it is not already marked. Suppose let's say one element is already marked, that means we do not want that particular element. So we are going to pop that from the minimum heap, and then we are going to find that particular element which is unmarked. Suppose let's say if we got unmarked, that means we are going to pick that index, and then we are going to mark it as true, and then we are going to reduce the sum. And then let's say whenever we want to do the elements, and then all the elements are completely marked, that means minimum heap becomes empty. So whenever it becomes empty, we are going to come out of the loop, and then whatever the sum we have right now, we are going to push it back into the answer. So that will be the function for this. So what we are doing is we are taking the answer, and then we are taking the priority queue, and we are pushing all the elements into the priority queue, which is minimum heap. And then we are considering each query. For each query, we are going to mark the index, and then we are going to take the number elements, and then we are going to mark based upon that. And then at last we are going to return the answer. For this particular case, the time and the space complexity is going to be, the time is going to be n log n, because we are considering priority queue and then insertion and then deletion. And then for the space complexity, it is going to be big O of n. Why? Because we are taking the priority queue with the maximum space as big O of n. Yeah, that's all for this video. Thanks for watching.